My name is Paula Wright. My pronouns are she and her. My hometown is Austin, Texas. Actually, I grew up out here and graduated with a bachelor's degree in architectural engineering in 2004. And I've mostly stayed in Austin, but I did spend about 10 years East Coast, and now I'm back in Austin and loving it despite the heat. Um, I'm currently doing custom home design, which is a little bit outside of engineering and a little more artistic. And my hobbies outside of work include baking and playing tennis.
Awesome. Do you have something in particular you love to bake?
I love cookies. I do have a sweet tooth, and I enjoy, just some good old chocolate chip cookies and some cookie dough, of course.
Sure. So Paula, let's shift gears a little bit with you. So you're coming in from also a different industry. How does data come into play in your industry as an architectural engineer in the work that you're doing?
Yeah, so data has a huge part. It's a good question. And, I got even more ideas of how data impacts what I do as we've been talking. And the largest one I want to start with, and there's so many ways that data impacts building design and architectural engineering and all of the multidisciplinary things that stem from architectural engineering. But one that I think is really, really evident would be earthquake design for buildings. And, it used to be that if there was a catastrophic earthquake in California, almost everything would be lost and destroyed, and you'd have to level it and rebuild it. But now we can really have tools even built into structures, and we know so much more about how things have collapsed in the past from all of the data and the data collected in the geological side from the actual strength of the earthquake all the way down to how much did this building move during the earthquake. And so we've now been able to develop buildings that can withstand fairly substantial earthquakes and not collapse. Some of them may have enough damage that they need to be leveled and rebuilt at the end, but if we can preserve life through the field of engineering and keep the building at least intact to get everybody out of it, that's a huge win. And that has been purely from data science. Similarly, a lot of hurricane design, if we look into Florida and Miami and some of these prone areas on the East Coast, we can now build bigger buildings than we ever could before because we have more data on the hurricane wind strength, and we have more data on what the building materials are going to do and how we can most efficiently design something that can withstand a hurricane. And that goes all the way into, the codes, the residential code and the commercial building code. And the reason that those codes change every 3 years is because we have new data and we can design more efficiently and more safely.
That's very cool. And it makes me think about how so many people love this detective work. We like to figure things out and figure out why things are happening. And a lot of people go into STEM because they have that curiosity. And you're talking about some of that forensics work, lots like the CSI shows and those types of detective shows, figuring out from the data what has happened, why did this fail, and how do we make that better the next time and not have that happen, and then how that continues to improve as we are able to collect and make sense of more data along the way. That's
Exactly.
awesome. So let's talk a little bit more about architectural engineering, since that's the engineering that we're focusing on a bit as well today. Can you talk a little bit more about your pathway into architectural engineering and your career in this field? How did you get into this, and what's your work look like?
Yeah, so I have a very indirect path similar to a couple of others. It's been quite a good eye-opening experience of lots of things. I actually ended up in architectural engineering not completely on purpose. As a high school student, I really wanted to become an architect. And so I applied to University of Texas, and I had to have two choices. And I said, okay, choice number one is I want to go to the architecture school. And choice number two, well, I don't know. All I really want to do is be an architect, but here's this option that's called architectural engineering. So, that has to be close. So I checked that, and I did not get into the School of Architecture because it is just fabulous and difficult to get into. And I said, okay, well, I'll do this engineering thing. I don't really know anything about it, but I'll change in a semester. And I took my first semester in architectural engineering and loved it. And my eyes were open to the fact that I could still have a hand in designing homes or commercial buildings, even with an engineering degree instead of an architecture degree. So I stuck with it and loved it and enjoyed the physics aspect of things. And then here I am.
That's awesome. And understanding the intricacies of architectural engineering once you got there and some of those differences. I think sometimes that's hard for our incoming students to understand maybe what are those differences. And we probably have a lot that are in that same boat of you. If either of those is fine, surely they're closest to the same. Can you maybe explain now? Do you have an understanding you could share with the rest of us of what kind of is that difference between an architectural engineer, an architect, and even maybe a civil engineer or structural engineer? Like, how do they all come into play in these, and how does that work in a house maybe or a building?
Okay, so what I'm going to use as my example, because I'm a very visual, like let's have a mental image person, is picture your local grocery store that you go into. And the grocery store has had all of these trades involved in it. So first you go to the grocery store, you have to park somewhere. The civil engineer is the person who says, okay, we need a parking lot that has 247 spaces and we need to lay them out and it needs to drain correctly and they've got to have curbs and we need to have some green space and some trees. And so the civil engineer is going to do the components outside of the building, your parking, your sidewalks, all of the things that are going to help you get into the building and make sure that the site doesn't flood if it's raining and you're going to HEB in the pouring down rain. You don't want to walk through a 4-inch deep puddle. You want the parking lot to drain properly. So that's the civil engineering component. The overall look of the store as you're walking up to it, oh, it's a huge store. It's a smaller version of a store. It has a really tall ceiling at the entrance. That's a nice feature. The architect is going to be the one who says, okay, this is going to be 10,000 square feet. We need this many bathrooms and the bathrooms are going to be over here. We need a place for people to put their carts and that's going to be over here. And they kind of lay out the general configuration of the building, the ceiling heights of the building, and the way the building is going to look from the outside. They give usually kind of some idea to the structural engineer then of like, we would like to only have columns right here. And then the architectural plans are sent to your structural engineer. And your structural engineer is going to design the foundation first and say, okay, we need a foundation that is going to be pertinent and strong in whatever kind of soil condition you have. Here in Central Texas, we are lucky to have a lot of rock in some areas, but we have some not so good soil in other areas. So your civil engineer has to design the foundation. They have to design all of the roof support overhead to make sure your roof doesn't fall in. All of those trusses, when you look up next time you're in the grocery store and all of the column locations, they have to design the size of those columns and how big are they and how close are those trusses and how beefy are those trusses. So they put together all of the structural elements, kind of the wood, steel, and the concrete of the building. And now it's cool because where architectural engineers fall in is this is an awesome broad basis because in architectural engineering, you learn a little bit about the structure, you learn a little bit about the architecture, you learn a little bit about the parking and the stuff that has to go outside of it, but you also learn about the mechanical systems that have to condition it and take all the, evaporative stuff out and cool it properly so you're not freezing cold. All the electrical systems that have to run your freezers and keep it good. So you learn about it, the entire building envelope and the insulation systems, and you look at the whole building as an entire element that can function best for its users. My architecture courses that I took while I was getting my architectural engineering degree were some of the best. I loved every single one of my architecture professors, and it really did force me to open up my mind. And still to this day, I mean, that's what I do now is more on the architecture side. I've really come full circle. I did forensic engineering, I did civil engineering, I did structural engineering, and now I've come full circle to do the architectural design, using all of that as a background to design some beautiful buildings, but that I know that I'm not going to have the engineer yelling at me saying, you can't actually do this.